Howdy fellas, today we are going to teach you how to find the determinant of a matrix. Okay, determinants are really important for indicating whether or not a matrix has an inverse, which could be the next lesson. Okay, so determinants only work for a square matrix, so this has to be 2 by 2, 3 by 3, 4 by 4, 5 by 5, etc. We're pretty much just going to work on 2 by 2 and 3 by 3 today. So that's good for you. The order of the determinant tells you, or is defined by the number of rows and columns in matrix. So a 2 by 2 matrix is going to be second order, 3 by 3 is going to be third order. Okay, great. How to calculate this stuff? It's not a very difficult calculation for 2 by 2. It gets a little more complicated with 3 by 3. But the calculation for a 2 by 2 is just that you cross multiply and subtract. So cross multiply top left to bottom right first, and then cross multiply bottom left to top right. That's the second part. All right, and then you subtract those two from each other. So what we'll have the determinant. Okay, so this is matrix A. The way that you write the determinant is determinant of matrix A. All right, you write it the same way as a normal matrix, but with just vertical lines instead of the brackets. So you might just see this vertical line with the brackets, and you'll have to know that what you're supposed to do with that problem is find the determinant. Okay? So what we'll do is we'll do the multiplication. All right, so it's going to be 3 times negative 2 minus the blue part. Okay, negative 4 times negative 1. All right, and then you just finish that up, and we'll have negative 6 minus 4, which equals negative 10, and that's our answer. Okay, very, very simple. Now, one special case here is a diagonal matrix. If you happen to have a diagonal matrix, and the diagonal matrix is defined by something that has all zeros except for the main diagonal, like an identity matrix, so that top left to bottom right diagonal, if your matrix happens to have that only non-zero numbers there, then you can just multiply all those together to get the determinant really quickly. So the determinant of B here is just going to be negative 20. Okay, that's a really special case. You won't use too much, but it's just a nice little trick to. Okay, some examples. This one, very simple determinant of this 2 by 2 matrix. Okay, so you need to cross multiply, subtract. So we always start with the top left to the bottom right. So we'll have 0 times 10 minus 8 times 1. Very, very simple. 0 minus 8, negative 8. Great. Now, 3 by 3s. Okay, we're going to do 2 3 by 3 matrices. These are a little bit different. All right, we're going to basically break these down into 3 2 by 2 matrices. And this is how you're going to do it. Okay, so first we'll start with the first element of the first column in the first row. All right, when you choose that element, all right, you're going to scale that element by a 2 by 2 matrix. Okay, so you can use that as a scalar. But you cancel out everything that's in that row and in that column. Okay, so this is our 2 by 2 matrix that's left. So this is going to be negative 3 times the determinant of 0, negative 2, 4, 1. Okay, that's the first part. Now you have to do that with the other two in that first row, the other two elements. Okay, so to do the second one here, we'll use 1. All right, those go away, and there's your 2 by 2 matrix. The only problem is the second element, the second part, the middle part here, is always subtracted. Plus, minus, plus. Okay, plus, minus, plus. So we've got 1 times the determinant of 1, negative 2, 1. And we need our third part here. Oh, I got to do some erasing. Okay, third part. We've got 0 here. Those go away, and there's our determinant. So we've got plus 0 times the determinant of 1, 0, negative 2, 4. Okay, now you can do all the calculation. All right, once you get it all laid out like this, it's just normal 2 by 2 matrices. You just have to do it 3 times. Let's see how it works out. So we have 0 times, we'll have negative 3 times 0 times 1 is 0 minus, so plus 8. Alright, this one we got minus 1 we don't need to worry about. We've got 1 minus 4. And this final one's going to zero out because of the 0 here. Okay? So finish it up. We have negative 24 plus 3 equals negative 21. And you're done. Alright, we'll do one more of these examples and then let you work in class. So, same idea. You've got to cancel out with our first element. We're going to use our first row again. Don't forget we've got plus minus plus up on top here. Okay, so this equals 2 times the determinant of 8140. Get some erasing. Okay, the red one is going to be negative 5. Get rid of those. Remember, this has to be subtracted, so it's not minus 5, it's going to be plus 5. Okay, minus a negative 5. Oh, that's a big 5. Okay, determinants 0, 1. It looks like an eyeball. Negative 5, 0. Okay, this is not a diagonal matrix because the zeros are in the wrong spot. So don't get yourself confused there. And the last one, with our 3, those go away. Plus 3, determinant 0, 8, negative 5, 4. Okay, do the quick calculation. I'll have 2 times 0 minus 4 plus 5 times 0 plus 5 plus 3 times 0 plus 40. Okay? And when you work this out, you should get negative 8 plus 25 plus 120, which is going to come out to be 137? Yeah, 137. And that's your answer. That's the determinant. Peace out.